Okay, so we find out, you can see this is the harvest readiness. So this place, this type of this layer, I just open only one. So this type of place is the harvest readiness place. Okay, this type of place, harvest readiness place, we find out. Then this is the compare NDVI. Okay, NDVI recent and pre, we can also compare. And pest like stress, we find out this type of map for the pest like stress. If you check the color, so here is the high and here is the low. So red is the high pest stress and blue is the low pest stress. And finally irrigation priority. So we find out this type of color is indicating about that more irrigation priority. If you check the color, so it's the high irrigation priority, it's the low irrigation priority, this type of color, it's a moderate. So now how I can create this type of things, I try to explain about the method. Okay, so first of all, we simply define our study area, then I simply just put the time period season, then apply the same process, just compute the NDVI and NWI, and also just use this code to remove the cloud and haze, and we just make a function. Okay, just we make a function. So this function further we simply connect with our collection. So this is my collection, I simply connect using the map function. Okay, so I simply connect these things with my map function. After that, we simply count how many images is available. We find out that 86 images. Okay, then it's not needed, it just show the. Okay, then we simply.
What is that? Sorry, sir.
Which
Sorry,
one?
sir.
Yes.
Image algorithm.
Okay, so in this time, so this thing is neat. Suppose there is no image. Suppose in this time we find out 0 image or null image. Then it just try to check these things. Okay. Okay, it just, you can check. It show the result. Okay, we find out the same. You can see effective count 86. Okay, same image collection. Suppose I find out there is null image. Then we try to use these things. Is there really some image is available or not? Okay, we try to check it. And I can see it also increasing the cloud level, it is 80%. We try to check it, but it's not the effect, but same process to check the image is available.
Image.
Yeah. So now we find out this, we compute NDVI and also compute the NWI. So we just simply compute average NDVI and average NWI. I already make the code, you can say I already calculate NWI and NDVI and connecting with my collection. So I simply call the collection is these things I simply call and simply calculate the average and also calculate the average for NWI. Simply calculate and then calculate LST. Okay, and compute the LST. Okay, and this LST we simply convert into your reproject the scale and also convert into 2.731 degrees Celsius. Okay, and then we simply calculate the soil moisture also. Okay, this is soil moisture and compute the soil moisture, and further we simply compute the average soil moisture. Okay, and also talk about that evapotranspiration data. Okay, basically ET or evapotranspiration data, which also use in here for that ET evapotranspiration. Okay, we find out the 15 images, and now we calculate the sum. Okay, total evapotranspiration. Okay, we calculate the total evapotranspiration, and then we just use the algorithm. So in this algorithm, we define the size greater than 0 and also multiply this value to basically these things. It's the reprojected the scale value of evapotranspiration. Okay, and then finally click with the study area. So now we find out this type of data. Suppose evapotranspiration data, LST data, or also other data, we need to normalize. Okay, self normalize 0 to 1. So for that, we simply take the 3 argument, image, region, and fallback value. Okay, so this 3 argument I simply put and just I compute the function. Okay, so using for LST we take the percentile, 95% percentile we take and compute. Okay, and then I simply apply this algorithm for the 95% percentile for each data. Okay, and then you can simply put the fallback 0.5 we put in here, and then we take the NDVI. This is my function variable name. I apply the NDVI mean. This is my study area. This is my fallback 0.5, and same process all of those. And now for irrigation priority map, how I can create. So for that, high ET plus low soil moisture plus low NDVI. Okay, so this thing, suppose if the high ET value, high evapotranspiration value, then low soil moisture value and low NDVI value, it's indicating about that higher priority of irrigation. Okay, so if the high value of evapotranspiration, low value of soil moisture and low value of NDVI, it's indicating about that higher priority of irrigation. So just we simply call this, I simply call the ET. Okay, so again evapotranspiration is simply normalized because I don't add in here. So again I simply call the ET, I call the function, I call the ET sum. This is my field and this is fallback. So simply just apply this formula. Okay, so apply this formula and then we put the its irrigation priority. And then we simply check this type of result for the irrigation priority. So we find out this type of color is the low priority, this type of color is the high priority. Okay, because this type of place is the low ET value. Suppose if you check, suppose this type of map, just click on here. So we find out the low evapotranspiration value for this type of map and then low soil moisture value. Okay, and find out that low NDVI value for this type of place. So that's why it's the higher priority of irrigation. Okay, and finally we simply add this type of map and then pesticide target mapping. So basically stress not explained by water. Okay, NDVI drop with normal and NAWI and LST. So that's we just identify pesticides. So water stressed we try to identify, then canopy stressed. So then further simply subtract the canopy stress and water stress. Okay, just simply subtract. Then we find out the pest like score. Okay, or where you need the pesticide. So then basically water stress, canopy stress minus water stress. Then we find out that pesticide like score. So where you need the pesticides. So this thing we simply add in here. So you can see the pesticide like stress. So we find out this type of place is the high stress of the pesticide. Okay.
Sir,
Yeah.
I think these mathematical methods of identifying the water stress, maybe the irrigation priority stress, those are the mathematical equations, is it?
Yes, it's mathematical equation. Okay, so this is the mathematical equation. So first of all, we just compute the water stress and canopy stress. So water stress, when you just simply subtract the canopy stress minus water stress, then we find out the pesticide stress. Okay.
Yes.
Then we find out it.
So I think it will be better for me and easier to learn if those mathematical formula will be written maybe in a PDF or in a slide. You like those formula, so that when I read this code,
so I will send you some reference paper about that. Okay, suppose this type of paper, formula? It's also available in the research paper also, this type of formula. Okay, or also some also some academic book is also available for the precision agriculture. So then you can easily get this type of formula or this type of interpretation. You can easily get from this type of book.
And the book, okay, you will send me even the book so that I can be easy to learn and understand the code and those questions.
Okay.
Okay, sir. Thank you. Low battery your computer. Okay. Now it's okay.
Okay, so now it's connecting my charger. So now we find out this type of place is the pest like score is very high. So now we try to identify for harvest readiness. Okay, harvest readiness, how we can easily identify. Suppose if you check, this is the this is the layer about that. So this type of place or this type of place is the harvest readiness place we can identify. So how I can do it? So for that we just apply another things. Suppose we simply define a date. Okay, EE date for season on end, SOE basically season on end, and present start and prevent start. Suppose I take the advance minus 21, and now advance minus 42 days. Okay, so recent start and prevent start we take, and also take the now. Okay, so basically it also depend on the crop calendar also, minus 21 day or minus 42 day. Okay, for harvest we can also get the recent start or prevent start. So in this case I take the minus 21 and minus 42, and NDVI recent we compute, and also NDVI prevent we compute, and also NDVI delta. And delta basically NDVI recent minus NDVI prevent. Then we find out the NDVI delta. Okay. So now from the NDVI delta, we just take the value less than negative 0.08. Okay. And it's indicating about the harvest ready. Okay. So now what is the method? This method is that we need to set the recent start date. Suppose I take the minus 21 days and prevent start date, advance minus 42 days, and then we simply compute the NDVI for recent start and now. Okay, you can see now basically this, and select the NDVI and compute the median and clip with my study area. So NDVI prevent. Okay, same process for the NDVI delta. NDVI delta basically subtract the NDVI recent and NDVI prevent. Okay, then we take a threshold value and then identify for the harvest ready study area. So we find out this type of place is ready for harvesting. Okay, and finally, okay, it's not neat. Then we simply export all of those together. Suppose all of this map, okay, for GeoTIFF file format and represent in our research paper or presentation. So this is the way we can easily identify for harvest readiness, then pest like stress and irrigation priority. Okay, for any cropland or any study area. So then we simply define it. Okay. Okay. So now we talk about that another things. It's called the SOS, POS, and EOS. How we can identify this type of date. Okay. So it's one kind of phenological model. Okay, phenological model. We find out the crop calendar idea. Okay, crop calendar idea. So this is my cropland. So I simply use this function to remove the cloud and haze. Just I create a function for make the NDVI. Okay, and connecting with my image collection. So this is my image collection. I simply connect these things and also connect these things. Simply connect, and then I simply, okay, it's not neat. It's not neat. It just simply check the image size. Okay, and also compute the modis. Okay, modis. I simply take the modis NDVI also. So this is the modis NDVI data. And further, okay, you take the NDVI algorithm. Okay, it basically this algorithm, if it just try to check if the image is available or not. Okay, otherwise it's also okay, there is no problem. Okay, and further we simply take the field simplify 30. Okay, and get the NDVI average result, and image with NDVI mean, it's calculate how many images. You can see image with NDVI mean, we find out this is the image. So now we peak of season. Okay, peak of season, POS, peak of season. This is the date about the peak of season. Okay, so now how I can compute this date, I also discuss about that peak of season. So for that we simply NDVI with stats, we compute the NDVI, and then we simply call this NDVI with stats short with NDVI mean, and take the first. I take the first date, first basically first item, and first item is indicating about the peak of season. Peak of season we find out from in here, and this first item further is simply just display the result in here, peak of season. So this is the peak of season. Okay, basically this date when you make the time series chart, suppose crop growth, where is the crop growth or crop growth? Yeah, this one, basically this time. Okay, suppose for that POS is the January 30, peak of stage is the January 30, and if you check this value is the negative, it's not the crop peak of stage because there is no crop, negative value we find out. But when you check, we find out this is the peak of stage, January 30. Okay, these things, this value basically it's calculated in here. This peak of stage simply calculate in this code. It's called the POS. Where is it? It's called the POS. Okay, peak of stress. We simply calculate. Then we calculate the maximum NDVI. Okay, so it's called the maximum NDVI, because if you check in the chart, we find out that maximum NDVI. So it's called the high stage of crop NDVI. So for that we also calculate the date. We can also get the date from, you can say, the May 24, but this type of date we can also compute using the formula. So for that you can see I just calculate the maximum NDVI, okay, and compute the maximum NDVI and also apply the threshold value. Okay, so in this time I take the threshold value and suppose greater than 0, and it's EOS, basically end of season. Okay, end of season, we find out the date. If you check, we find out the maximum NDVI 0.6 and SOS. This is the end of season. End of season, basically your last time period we find out in here. Last time period. Okay, last time period, basically harvesting time. End of season, harvesting time. Okay, and you can see we just simply label all of those, and this is the peak stage of the NDVI, and this result it show only for that specific marker. So this for this land, we find out this type of result. Okay, so I take the field. If you check it, January 1, 2023. So we find out that this one, season of start. Okay, SOS mainly season of start. So this is the season of start. We can find out, you can see also from here. Okay, then it show the peak of stage, POS 23, 25, 25, peak of stage 25, 25, 21, 25, what's 25 January, or 25 okay, March 25 March. You can see peak of stage, it's the highest maximum value. And finally we find out the another one, it's called that end of season, 25 December. It's the end of season, 25 December. This is the end of season. Okay, end of season. So basically it's called the phenological model. This phenological model, date, POS, SOS basically start of date, then POS peak of stage, and finally EOS end of season. So this date we can also compute from the crop growth monitoring. Suppose just make the chart and you can easily identify this type of things. In this case, if you check peak of stage, season of start in the January 30, then peak of stage the highest value. Okay, then find out that this one is the end of season, because you can say other is the not the crop, it's the negative value. So this type of information you can also get from this type of chart also, but it's computed theoretically. Okay, it's this code help you compute this type of value theoretically. EOS date, okay, or POS date or SOS date, it compute the in here. Okay, but we can easily get this type of phenological start of season, peak of season, end of season from the graph of NDVI or any other indices, EVI. We can easily get the idea. Okay, so you can also export this type of result as a CSV file also. This type of SOS, POS and EOS data, we can also export it as a CSV. Okay, so basically this is the process. Okay, so as of today's session I discussed about the lot of topic. So I also send you some book about the agriculture precision. You also try to read it, then you get some theoretical, and further you also try to practice this type of code. Okay.
Yes sir, yes sir.
Okay, so today's yeah, please.
But you said about that, I asked you about, if you remember, about the issue of banana plantation here.
Okay, banana.
And you suggested that you have to use And you suggested to use maybe the DSAT method, the
Okay, yeah, okay.
method.
Okay, so
And you
okay,
said we.
yeah. Okay, so I'll try to create this type of method and try to explain for the next class. So this is the way for the crop yield prediction using the ground truth. But when you don't have the ground truth, then how we can easily make. So I'll also discuss inshallah next class about that. Then you can easily get the idea. Okay, I'll try to make it the material for this course. Then you can easily get the idea. No problem.
Okay, but also it is possible to make the crop prediction, the prediction using the deep learning, or it's only machine learning.
Yeah, deep learning is also possible, no problem. So I also try to share with also deep learning model, some deep learning model. Okay, no problem. Okay. Okay. And basically this is our total 10 days program, no problem. I hope it also cover all of those properly, no problem.
Okay.
And if possible, also try to make the payment for this week. Okay, then it's more better.
Yes, this week I'll finish the
okay,
payment.
Thank you.
I think we'll meet on Monday, is it?
Okay, Monday. I will knock you, no problem.
Okay. Thank you.
Okay, thank you. Have a good night. Bye.
Thank you.